In statistics, the standard deviation is a measure of the amount of variation or dispersion of a set of values. A low standard deviation indicates that the values tend to be close to the mean of the set, while a high standard deviation indicates that the values are spread out over a wider range. The standard deviation of a random variable, statistical population, data set, or probability distribution is the square root of its variance. It is algebraically simpler, though in practice less robust, than the average absolute deviation. A useful property of the standard deviation is that, unlike the variance, it is expressed in the same units as the data. In addition to expressing the variability of a population, the standard deviation is commonly used to measure confidence in statistical conclusions. For example, the margin of error in polling data is determined by calculating the expected standard deviation in the results if the same poll were to be conducted multiple times. This derivation of a standard deviation is often called the standard error of the estimate or standard error of the mean when referring to a mean. It is computed as the standard deviation of all the means that would be computed from that population if an infinite number of samples were drawn and a mean for each sample were computed. The standard deviation of a population and the standard error of a statistic derived from that population are quite different but related. The reported margin of error of a poll is computed from the standard error of the mean and is typically about twice the standard deviation, the half-width of a 95% confidence interval. In science, many researchers report the standard deviation of experimental data, and by convention, only effects more than 2 standard deviations away from a null expectation are considered statistically significant. Normal random error or variation in the measurements is in this way distinguished from likely genuine effects or associations. The standard deviation is also important in finance, where the standard deviation on the rate of return on an investment is a measure of the volatility of the investment. When only a sample of data from a population is available, the term standard deviation of the sample or sample standard deviation can refer to either the above-mentioned quantity as applied to those data, or to a modified quantity that is an unbiased estimate of the population standard deviation. Logan gives the following example. Furness and Bryant measured the resting metabolic rate for 8 male and 6 female breeding northern fulmars. The table shows the Furness data set. The graph shows the metabolic rate for males and females. By visual inspection, it appears that the variability of the metabolic rate is greater for males than for females. The sample standard deviation of the metabolic rate for the female fulmars is calculated as follows. The formula for the sample standard deviation is where x1, x2, xn displaystyle text style x_1, x_2, l dots, x_n are the observed values of the sample items. X displaystyle text style bar x is the mean value of these observations, and n is the number of observations in the sample. In the sample standard deviation formula, for this example, the numerator is the sum of the squared deviation of each individual animal's metabolic rate from the mean metabolic rate. The table below shows the calculation of this sum of squared deviations for the female fulmars. For females, the sum of squared deviations is 886,047.09, as shown in the table. The denominator in the sample standard deviation formula is n1, where n is the number of animals. In this example, there are n equals 6 females, so the denominator is 6 minus 1 equals 5. The sample standard deviation for the female fulmars is therefore for the male fulmars. A similar calculation gives a sample standard deviation of 894.37, approximately twice as large as the standard deviation for the females. The graph shows the metabolic rate data, the means, and the standard deviations for females and males. Use of the sample standard deviation implies that these 14 fulmars are a sample from a larger population of fulmars. If these 14 fulmars comprise the entire population, then instead of the sample standard deviation, the calculation would use the population standard deviation. In the population standard deviation formula, the denominator is n instead of n1. It is rare.